In this video, we're going to do an overview of collections. So we'll be talking a lot about collections later in the semester. So don't feel like you have to understand all of this now, because a lot of this is going to be preview of what we'll see several weeks down the road from here. But what I want to do with this video is give you just a broad overview of collections. So this module, the intention is just to give you an idea of some of the things that you'll need to know when you're working with collections. Starting in the next module, we'll actually be building these collections ourselves. And once you start doing that, it'll help some of the concepts make more sense to you. So a collection is an object that contains other objects. It should provide methods for accessing and managing its elements, and may also have methods for updating the elements somehow, just depending on what the specific collection is. So here's sort of an abstract view of what a collection looks like. So the collection is here in green, and it contains a bunch of objects that we'll call elements. Now, the exact nature of these objects is irrelevant to the collection itself. It just knows that it has a bunch of object references to some objects, and we'll actually talk about that later in this video. So it stores these elements, and it also contains methods for dealing with these elements, doing something with them. Again, the specifics here depend on the specific type of collection. Now, some of these methods are going to be public-facing, and those methods make up the interface of the collection. That interface is what clients that use the collection use to actually add, remove, and manage elements inside the collection. So again, the idea here is we have just a bunch of stuff. The collection abstracts that idea away to allow the client to interact with those elements using a simplified interface. Now, these collections can be linear or nonlinear. The client doesn't care, only the implementer of the collection. Now, there are cases where a linear collection is more efficient than a nonlinear collection, or vice versa. But in general, as far as how they're used, they typically tend to be used interchangeably. So here's an example of a linear collection where we have objects that are basically stored in order in the collection. Now, when I say in order, I don't mean alphabetical order. I mean they're stored in some order. So there's some notion of this one is first, then this one, then this next one. Here's the last object. Whereas with a nonlinear collection, it's basically just a big pile, and there's no real notion of what's the first object, what's the last object, and so forth. And you can see we put objects in, we take objects out. Now, Java has several built-in collections that are part of the Java Collections API. Here's a very high-level overview of what those are. Maps are not actually collections, but in a lot of ways we can treat them like collections, and we'll actually talk about them in this module. For our purposes, we're mostly going to be focused on lists and queues and maps. And so you don't need to memorize this framework. This is just provided so that you see there's a whole bunch of different things. So as you learn more and more about Java, you should try to learn more and more about the collections that are available to you. But there's a lot of collections, way more than we would have time to cover in this class. And so we'll touch on a few highlights, and then once you understand a few of the collections and how they work, you can apply that knowledge to learn additional collections later on. Now, our collection is an object itself, but it's going to store other objects. So it's going to have some sort of underlying data type to hold those elements. Now, when I say underlying data type, I just mean what it's storing the objects in. So you may say, well, why doesn't it store the objects in a collection? Well, it in theory could, but remember, at some point, we have to have some low-level data structure that the collection uses. Because yes, one collection could use another collection to store its elements, but then what does that collection use? Eventually, we have to have something concrete. And the two main implementation styles for this underlying data structure would be either to use an array. So here's an example of a list that's using an array as its underlying data structure. We could also have what are called linked structures, where we just create some object that holds an element, and then we link those together by references, and those can be linear or nonlinear data structures. Now you may say, so arrays are linear and these other things are nonlinear, and actually you can have a nonlinear data structure stored in an array. So we'll see an example when we get to trees. We'll show you how to store a tree in an array. A tree is a nonlinear data structure, but you can store it in an array, or you can use a linked structure. Keep in mind that this is a really high-level overview. We're going to get into the details of all of these things. In fact, you'll see some of these images later on in the semester. So if it doesn't make sense to you, or if it's overwhelming right now, don't be too concerned. The point is not for you to understand all this now. This is just to sort of give you an overview so that you know what to expect in the future. Now, one important concept when it comes to collections is the idea of generic types. All of our collections are going to use generic types. So generic types let us write collections that hold any type of object. And what it means is we're not going to say what type of object we're holding. We're going to use a generic type. So when we declare the class, notice we have this T in brackets here. And when we talk about the interface that it implements, that's also a generic interface. And the bag interface is one that we'll actually see in an assignment. So this would define our class. That's a generic class. And of course, I would need to have constructors and methods and so forth. But anywhere in my class, I would just use T to represent the name of the object type that the collection's holding. Now, there's nothing special about T as a letter. E is common, G is common. There's different letters that are common depending on what exactly is meant by that type. But ultimately, it doesn't matter what that is. I'll use T and E for the most part. But the specific letter used isn't that important. So once we have a class that's a generic class, we can instantiate it. And when we instantiate it, we specify what type it's going to store. So here we have collection 1 is an integer collection. Collection 2 is a record collection. This is the only place that we actually specify what type is being stored in that collection. And so there's a lot of code examples for you to go through in this module. And you definitely want to try to learn as much of it as you can, but just keep in mind that we're going to be coming back to these ideas over and over in the next few weeks. In fact, we're going to spend the next 2 weeks just on list type structures, just so that we have plenty of time to spend so that you understand how all these things work together.